Sigma notation is good for finding sums of arithmetic series when there are a small number of terms, but in general, it's tedious to write all the terms then add them up. A more efficient strategy is to make the connection between sigma notation and the sum formula. Let's evaluate this sigma notation. First, we're going to change it over from sigma notation to our formula. So here, we need a sub 1, which is going to be when k equals 1. So when k equals 1 here, that's 3 times 1 minus 5, which is negative 2. And then we need to plug in 35 to get a sub n. N in this case is 35. So a sub 35, 35 times 3 minus 5 is 100. So now we have n, which is 35 over 2 times negative 2 plus 100. And that right here is 1,715. Let's evaluate this sigma notation. This series is a little bit different since the starting value is not 1. As you can see here, it's 10. The summation formula applies to summations that start with 1. In order to calculate the sum of a large sequence when the first term is not 1, we need to use this formula more than once. Simply find the sum from 1 to 30 and the sum from 1 to 9. Then subtract them. Alright, so we're going to break this up into two pieces, from 1 to 30 and from 1 to 9. And then we're going to subtract this portion from this portion. So over here, we're going to calculate from 1 to 30, over here from 1 to 9. A sub 1 is the same for both. That's going to be when d is 1, 4 times 1 plus 2 is 6. A sub 30 is what we're going to use over here for a sub n in the formula. And that's 4 times 30 plus 2 is 122. When we plug it into the formula, n is 30 over 2 times a sub 1, which is 6, and 8 plus a sub n, which is 122, gives us 1,920. Over here, we have a sub 9. A sub 9 is 4 times 9 plus 2, which is 38. So we use the formula, and we see that s sub 9 equals n, which in this case is 9, over 2 times a sub 1, which is still 6, plus 38, which is a sub 9, giving us 198. So then we just take the values that we figured out on the previous slide, 1,920 minus 198, giving us a solution of 1,722. There is a second method that involves a slightly modified formula for when you're starting with a number that is not 1. Here you can see instead of n over 2, it's n minus c plus 1 over 2 times a sub c, which is our starting value, plus a sub n, which is our ending value, where c and n are natural numbers. This series has 21 terms, which is found by using the formula n minus c plus 1. It's tempting to say 20 terms, but you need to include the beginning term, i.e. the 10th term in the sequence, which explains the plus 1 at the end of the fraction's numerator. Let's convert the sigma notation to our revised formula. So here, we're going to plug in 30 minus 10 plus 1 over 2. So that's going to be 21 over 2, as you can see here. We're going to need a sub c, which in this case is plugging in 10. So 4 times 10 plus 2 gives us 42. And we're going to need a sub n, which in this case is 30. So 4 times 30 plus 2 equals 122. So then we have our formula here, 21 over 2 times 42 plus 122 equals 1,722.